approximation. And I can't on this calculator turn a decimal back into a radical form. So what you're going to need to do is 96 square root 3. Let's see what that approximation is. Okay, it's not the same. Let's move on to 900 square root 3. Okay, not the same. Let's move on to 363 square root of 3 all over 2. And we've got a match. There we go. And you could check the last one too if you needed to. Okay. Our next question, I'll show you this one actually using the radical form. So we have a base of our triangle, and it says it's regular, so it's equilateral. That means this side is also 28 root 3. I'm going to draw in a height here. So the base of this triangle is 28 root 3. I need the height, and then I can divide it by 2. So the height is that little, this line here that I drew in. So I'm just going to focus on this little half triangle here. That's a 30, 60, 90 if it's regular. These are all 60s. 60s cut in half, that's 30. Remember, a hypotenuse of the triangle is double the length of the short leg. So this would be 14 root 3. You could also get that by taking this side, 28 root 3, and just taking half of it. Now for this side here, from short leg to long leg, we are multiplying by square root 3. If you forgot that step, you could always use Pythagorean theorem as well, but really what's happening is root 3 times root 3 is root 9, which is 3. So really we're multiplying 14 with 3. And I believe that's 42, so 14 times 3 is 42. All right, so our height is 42. So we have the base, we have the height, and it's just this one triangle, so we don't have to multiply it by a number of triangles. So we've got 28 square root 3. We're going to multiply that with 42, and that's all over 2. Oh, and this one gives me my decimal format as well on my calculator. Let's write that down. Okay, or 6. Now I would just need to compare. 16 square root 3 is not going to work. 300 square root 3, also not the same. 48, whoops, square root, no, let me clear this up. 48 square root 3. All right, it's got to be this last one. Yep. What you could have also done is just multiply 28 and 42. Divide that by 2. So now I've just multiplied the numbers out, and I'm left with 588 root 3. That also works. Okay, question 17. The perimeter of this shape is 63, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So 63 divided by 9 is 7. So this entire side length here is 7. And what I'm going to focus on is this little half triangle that comes from the inside of that shape. And I'm going to draw that a little bit bigger here. And since I just made a little half triangle, I'm going to take 7 and divide it by 2. And to find the area of this entire shape, I'm going to focus on the area of this one triangle here. So we know the base of that triangle is 3.5. We don't know the height, so I'm going to leave that blank. And this little half triangle, there's actually 18 of them. And the reason why is there's 2 on each side and there's 9 sides. So 18. So this is the height, base times height divided by 2 times the number of triangles. So the number of triangles is either going to be double the number of sides that you have or exactly the number of sides that you have, depending on if you're using a half triangle or a full triangle. Now this is 3.5, this is x. And in order to find this angle measure here, you'd actually have to take 360, and we're going to divide it by 18, because there's 18 of these little half central angles in this shape. So 360 divided by 18 is 20. So this is a 20-degree angle. So from 20 degrees, we have an opposite side, and we have an adjacent side. So we can use our tangent ratio. We can say tangent of 20, remember SOHCAHTOA, tan 20 equals 3.5 over x. And if we do a cross product, x gets multiplied with tan 20 to equal 3.5. So the only way to get x by itself is to divide by the tangent of 20. So we've got 3.5. We're dividing that by tan of 20. And we're going to get about 9.6. We can do 3 decimal places, 616. Okay, now all I have to do is plug these numbers into my calculator. So we've got 3.5 times 9.616 times 18, and we're going to divide that by 2. So our area is approximately 302.9. Okay, your process on the next question is going to be the same. I'll just help you get this first part set up. I would draw the little half triangle. This is now 1 instead of 2 because we just took half of it. And then this little angle measure here is going to be 360 divided by 10 because there's 10 of those little half central angles on that shape. So that would give you this angle measure here. You're solving for this side. So essentially you're solving for the area of this one triangle. And once you find the area of this one triangle, you're going to want to multiply it by 10 because there's 10 of those triangles in this shape. The last page that I'm going to go over was not on the original practice test, and it's not on the one that's on the CUDA online, but I have these questions on the test, so I wanted to go over them. And they're just different numbers, essentially. Okay, so our similarity ratio. Let me actually grab my toolkit here. This would be page 16 of your toolkit. Remember, similarity ratio, perimeter ratio, those are both the same numbers. And then our area ratio is just a squared version of that. So first question, similarity ratio is 16. Perimeter ratio, they need to be the same. They both represent something that is linear, or what we would call two-dimensional. So, or sorry, one-dimensional, a line, linear. So 16, it's going to be the same, 16. Our similarity ratio here is 7/3. I'm going to write it as a kind of stacked fraction. And what we want to know is the area ratio. So remember, area ratio is basically taking this and squaring it. 7 times 7, 7 squared, 49. 3 times 3, 3 squared, 9. This cannot be simplified, so it would be 49 over 9. I would want to leave it as 49 over 9. I wouldn't want to flip it. Since 7 is on the top, we want to keep the 49 on the top as well. Okay. Here, we have two figures that are similar. Our sides are going from 6 to 12. So 6, what are we multiplying by? Times 2 gives us 12. And we're looking at perimeters, missing perimeters. So we want to multiply by that same exact ratio. We have a side length that's linear. We have a perimeter that's linear. So we're going to multiply by 2. And that would give us 60. 30 times 2, that's 60. And then our very last question here, we've got our side length, 10 going to 50. Well, we're multiplying by 5 here. Okay, and actually I'm going to go backwards in that direction. Might be a little easier because it looks like this one we're going to have to go backwards as well. So 50, we're actually dividing by 5 if we're going backwards instead of multiplying. But that's for a side length. So for area, we can't just divide by 5. We actually need to divide by 5 squared because the area ratio is whatever a squared version is of that. So we're going to take 100, we're going to divide it by 5 squared, which is 25, and that should give us 40.